Welcome to the Stormsurf video surf forecast for the week starting Sunday, December 20th. First up, we take a look at significant wave heights for the North Pacific Ocean. We see a gale in the northern Gulf of Alaska, producing 28-foot seas, aimed mainly at Canada and the U.S. Pacific Northwest, not so much down into California, and another gale trying to organize here off Japan, but overall, not a particularly stellar pattern yet. As usual, we'll start our tour looking at jet stream level winds. These winds, up about 30,000 feet, help support the formation of gales, and when those gales do form, help direct their path. Right now, we have a reasonably healthy flow. That is, good winds pushing off Japan, working their way across the Pacific, but a little bit of a split is going on here at about 155, basically north of Hawaii. That is, the jets coming off Japan, good winds, about 160 knots, a little bit of a trough. We're looking for troughs. That is a dip in the jet like this that would support counterclockwise flow aloft and at the surface, and of course a counterclockwise flow at the surface is the indication of low pressure, and that's what creates gales. That is what creates seas and swell and therefore surf. Anyway, so the jet comes consolidated for the most part off Japan. There's some suspicion that there might be some sort of a split actually going on here, but it's not obvious. So it ridges slightly to the north here, up to 180 knot winds in this pocket, then splits north of Hawaii, with one flow going into Baja, the other into the California coast. Not really any trough here. Just here is the only real area supportive of gale development. Put this into motion, we'll roll this out, and that trough, very broad, very weak, and there's sort of not, the jet is just really not super consolidated here. You can also see indications of a trough right in here too, or something trying to go on, and then this ridging pattern over north of Hawaii. Anyway, as we roll through, notice the jet sinks further south come about Wednesday into California. That would be some indication of low pressure and or weather working its way into the California coast. Then the trough gets a bit better organized on Wednesday here south of Kamchatka, and much better into Thursday. Notice the jet and a actual real trough starting to form here, pushing into central California on Thursday night. Trough continues over the date line, and then the California trough starts moving inland. This trough that was over the date line moves towards the northern Gulf of Alaska, and winds then start building over Japan to about 180 knots on Saturday. That's more supportive of gale development. Another trough here in the Gulf of Alaska on Sunday. That's just after Christmas. And winds continue to build and more consolidated pattern, but this split just continues right here north of Hawaii into the 180-hour mark. So overall, the pattern is fairly indicative of a healthy winter pattern, somewhat El Nino influenced, and certainly out to about here. You really, if it's strong El Nino, you'd want to see this split point moving to more like just off the California coast, if not inland, just a consolidated flow running right across the North Pacific. We're not seeing that. That's probably attributable to the inactive phase of the MJO, which is still in control at this minute. Let's go down to the surface and see how the jet stream affects surface circulation. So here we go. Surface level pressure, surface level winds. Currently, high pressure, 1032 millibars north of Hawaii, exactly as one would expect typically when you see the jet stream split like it was in this area. High pressure forms between the splits. That's what we have here. A little bit of it trying to nose into central California, but also notice weak low pressure, 984 millibars up here in the northern Gulf of Alaska. And there's some sort of a dividing line between the high pressure and the low pressure right about central California. You can actually get hints of a little bit of a front right here. Okay, also a little bit of high pressure off of Japan, but much larger low pressure, and we've seen a lot of this. We saw the trough in this area, large low pressure, but not very organized, not very consolidated, and that's consistent with what the jet stream looks like. We'll start putting this into motion, see how things play out. Low pressure works its way Sunday night. We'll just look at that real close, not so much from a surf perspective, but maybe from a weather perspective for northern central California into Monday. More low pressure here in the western north dateline area. Another gale develops on Tuesday in the northern Gulf of Alaska. Remember, the jet is pretty energetic right here. It's supporting gale development, but just doesn't have a lot of open ocean. Also, another gale here come Tuesday west of Japan. Roll this out. This gale, actually storm 50-knot winds, pushes towards the Pacific Northwest into Wednesday, and the gale that formed here now storm status. But again, because of the ridging in the jet stream here, it pushes the gale to the north and then into the Bering Sea, just like we've seen several already in the past month or so. They form in the northern dateline region, get shoved north, and they're into the Bering Sea with just a fragment of their fetch unobscured or unshadowed by the Aleutian Islands. Roll this out. So high pressure here, but more weather just sort of working its way down the Canadian and U.S. West Coast. Low pressure hangs on Thursday in the Bering Sea, tries to make its way into the northern Gulf of Alaska, but doesn't do a whole lot. Another system forming right here in the northern dateline region again on Sunday, but again, mainly in the Bering Sea. But then this system here on Sunday, if one believes the model's that far out off North Japan, 55-knot winds, and starts building and racing towards the east at 180 hours out at storm status. Certainly good for west swell for the Hawaiian Islands if that were to form, but at 180 hours out, I would not believe it. So finally, the impact of those winds on the ocean surface. As we saw, winds are blowing in the northern Gulf of Alaska, small area, 28-foot seas, nothing too particularly interesting. And then another little fetch here off of Japan, only 18-foot seas, certainly nothing coming of that immediately. Here's this next sort of boundary area between low pressure in the Gulf, high pressure here, 20-foot seas off of the North California coast, but just nothing impressive at all. Just good for, and this is into Monday night, almost Tuesday, just basically a windy, rainy mess is kind of what it looks like. Another gale forms in the northern Gulf on Tuesday, falling southeast, 34-foot seas. At one point, it was much higher than this, up into 45-foot seas 2 days ago, but now a dose of sanity has come to the models, and that works its way into Vancouver Island. The next low here over the North Dateline region, again, all the energy is really in the Bering Sea and shadowed relative to either California or Hawaii. Then finally come Friday, some of that energy supposedly is to break free of the Aleutians, maybe 32-foot seas. Again, good for swell, mainly for the U.S. West Coast, kind of sideband energy working its way into Hawaii. The issue here is because of high pressure here, because of the split in the jet, all the energy, storm energy, is doing this sort of a track up into the northern Gulf of Alaska, and that tends to favor the Pacific Northwest down into central California or so. Swell angle is pretty much too steep for Southern California except select breaks. And what we really want is this split point to start moving east. That will open up the western Pacific and then start favoring Hawaii. We get into the coming weekend past Christmas, and again, more of the same sort of muddled pattern to the north until supposedly Sunday, when we get that gale or that storm with 41-foot seas. This would put in a good west angle swell for Hawaii, and certainly also for the U.S. West Coast. And just a quick inspection of the Great Circle path. So here's Hawaii. Here's the 304, 305 degree path into Hawaii. And see, you really want winds and the seas pushing down these Great Circle paths. So this system at 180 hours out would fit the bill as a good swell for Hawaii. For Northern California as well, too. You can see energy basically, if you're within 30 degrees of the Great Circle path, then you're okay. 100% of the swell energy generated here would actually arrive at this destination. And also for Southern California, that looks like about the 296 degree path, 295, something like that. So that would work. But when you get these storms up here in the Gulf of Alaska, relative to Southern California, it's all shadowed by Central California. I mean, really, your better shot for Southern California is these northern dateline storms. They have a direct path in, but once you get up here into the northern Gulf, not so much for Southern California at all. And also, here's another view. California here, Hawaii here, high pressure. See the trades blowing very strong over the Hawaiian Islands. Here's that front we talked about, just working its way into central California. We'll just sort of roll this out because the point being, here again, here's this boundary between high pressure at 1030 millibars north of Hawaii, and then low pressure up here in the Gulf of Alaska, and you can just see this steady onshore flow working its way into California nonstop into Wednesday. Trades finally start backing off Wednesday in the Hawaiian Islands, and yet more north winds, cold air, low pressure working its way down the California coast into Thursday, and then maybe a bit of a break here. Notice high pressure sort of sets up here, tendency for maybe northeast winds come Saturday or so. But then if you look at this, you can see more low pressure looking like it's just getting ready to spill into California come a week out. Hard to say how much, if any, of that will materialize. And then again, trades take over for the Hawaiian Islands. Very much this northern storm track kind of thing is a symptom of the inactive phase of the MJO, classic high pressure just sitting right here off the coast. One would think with a major El Nino in play, this would not be the case, but it is right now. We'll get into that a little more in a minute. And then we'll also take a look at precipitation, mainly towards California, because that's something we're very interested in. Certainly precip happening with snow in the mountains, light snow in Sunday night, and then another good pulse on Monday, much stronger odds for snow and rain into California, and maybe bits of it working its way into Southern California. Tuesday, that fades out. Then Wednesday, a bit of a break. Then Christmas Eve, another pulse, moderately strong in the Sierra, snow and rain down the coast. And then things kind of dry up into the weekend, and then the next system forms offshore, but hasn't quite made it inland yet by, Sunday a week from now. So the suggestion is there'll be swell, mainly from a northerly direction, but also a lot of wind, a lot of rain. So maybe that's not such a bad thing for right now. Get the moisture content up, at least in terms of California. But really what we want to see from an El Nino perspective is all this high disappear, see the jet come pulling straight onshore, maybe splitting just off the U.S. West Coast, giving it a little bit of a break here, but having a healthy storm track rolling through the northern dateline, or the dateline region into the Gulf of Alaska. We're not seeing that yet. So for now, let's start talking about El Nino 2015. Where's it going? What's happening? And what can we expect for the future? Because the future of El Nino is also what dictates the future of the surf. And we'll start our tour like we normally do, first looking at winds. And we're specifically interested in winds in what we call the Kelvin wave generation area, basically from 130 east, the far west Pacific, just on the equator, 5 degrees north and south of the equator, to about 170 west. So this area right here. Looking at this is from the TAO buoy array, actual buoys on the ocean surface, not modeled data, the real thing. Clearly we see a trade wind pattern, east winds north of the equator, and some signs of westerly winds, and that's really what we want to see, calm winds or west winds in this area. Especially if you're in a strong El Nino, you would expect to see a preponderance of westerly winds in this area. And we do not see that. That is all attributable, again, to the inactive phase of the MJO, which should not be in play at all, at least per most theories. And yet here we are in the supposed depths of El Nino, and the inactive phase of the MJO is just sitting right over top of the Kelvin wave generation area and basically preventing west winds from forming. That in turn robs energy from the jet, makes it less strong than, not as strong as it would be normally, and then that in turn sort of puts a damper on storm production. So clearly these are actual winds, trades in control. Anomaly-wise, differences in normal for this time of year, we still are eking out little signs of westerly anomalies, but nothing very significant at all. I mean, pretty darn right disappointing for this point in time. And again, here's a look back in time. CDAS 850 millibar winds up about 4,500 feet, but a good proxy for what's going on down at the surface. Again, the area we're concerned with is draw a little box right in here. And if there were westerly anomalies, there'd be red. See, here's your westerly anomalies here off towards the Galapagos and south of Hawaii. Then we just go for the past couple of days. Notice there's been a little hint of building westerly anomalies through the 18th of December, but nothing particularly strong or obvious yet. And here's the 0Z Sunday actual winds per the GFS model. And what you see clearly, and we saw this in the TAO array data, easterly winds, trades, and this is what, about 16 knots blowing. So the Kelvin wave generation area goes to 5 north, and it's pretty much this area here between 3 north and 5 north where all the easterly winds are. But then you also notice here down at the southern end of the Kelvin wave generation area, little hints of westerly anomalies, but nothing significant, and a little bit here as well. But generally, you look at the whole area and you say, well, there's more east winds than there are west winds. So the tendency is more towards trades, especially north of the equator. So here's a way to go back in time. We've seen this before. The Kelvin wave so this is the West Pacific here, East Pacific here. The Kelvin wave, and this is the whole planet, wrapped on one picture, but the Kelvin wave generation area runs roughly down from here to somewhere over about here, and the reds would be westerly anomalies. And you can see in the November time frame we've had a pretty good run of modest westerly anomalies. We believe this was strong enough to help create a Kelvin wave. Again, when the trades reverse direction like they do in this sort of a situation here, it allows warm water that's normally in the West Pacific to start moving to the east, and so that happened there. But then we got into the December time frame, and look at this, it was almost easterly anomalies. Probably this is a little overstated. It was basically just dead winds, certainly not anything that would support Kelvin wave development. But now here we go. Here's where we are currently. Little bit of westerly winds, and as we go for the next week, again, this region somewhere right around here to here, we see westerly anomalies forecast to develop for the next week. This is a good sign. This puts us back similar to a pattern where we were in the late November, early December time frame. Again, maybe helping to support strengthen the jet stream some, and also support storm development, and also maybe push a little warm water to the east. So let's get right in here. Here's our Kelvin wave generation area. Here's the actual GFS model, wind forecast. So let's watch how this plays out. And you just watch here, you see easterly winds. And this is into Monday night, Tuesday, and then come about Wednesday, you start noticing a little bit more coverage of westerly winds here south of the equator. Not as big, not as strong as the easterly winds. But then here you get into Thursday, the pattern starts building a little bit more, and you get into Friday and Saturday, and it continues to hold, if not build. And so we still have easterly winds up here, but westerly winds, and what's that? That's 25 knots in one little pocket there, and certainly broader area here in the 16, 17 knot range. We keep going, and when we get into a week from now, we have a good area of westerly anomalies. Also, still a good area of easterly anomalies. The squeeze is kind of on which one's going to get the upper hand, but still, the fact that there is westerly anomalies, and we haven't seen most of the westerly anomalies this year have been mostly north of the equator, but now we're starting to see them at least forecast build south of the equator. This will be the first time in quite a while that we've seen any good solid westerly anomalies. This might be a hint, and this is a bit of a reach, but might be a hint that the MJO, the inactive phase which has been over this region, might finally be starting to let up a week from now, and this would help us move into a more normal El Nino pattern. And also notice that 180 hours from now, again here, the Kelvin wave generation area is down here. When you start getting those westerly anomalies here, notice the jet stream also starts building, much more energy coming off Japan, working its way to the dateline. So one of our viewers asked, well, how do the westerly anomalies affect the jet streaming? What's the direct correlation? I can't answer that exactly. What I can say, though, is that when the active phase of the MJO moves in this area, westerly anomalies or westerly winds tend to build in the Kelvin wave generation area, and that also fuels the jet stream. And so there's a direct correlation between the two. And once the jet stream gets going, then the storm track boosts up. And so what we've normally been doing, I mean, for decades now, is watching the MJO, looking for the active phases in normal winters, because when you get the active phase, the jet stream roars, the storm track comes to life, and it'll do that for 4 or 6 weeks, the length of the MJO, until the inactive phase comes in, and then it all falls apart. So you can kind of plan when there'll be periods of strong surf in winter months in the Gulf of Alaska and Dateline region based on MJO phases. So next we'll take a look at actual MJO forecasts. This is the statistic model. So blues are the active phase of the MJO. This is outgoing long wave radiation. Blues suggest less radiation, that is sunlight reflecting off the ocean surface, because there's more clouds, because there's westerly winds underneath it, because this is the active phase of the MJO. Reds are more sunlight reflectivity, the inactive phase of the MJO. So the Kelvin wave generation area that we're looking at right along in here, well, that's under mainly the influence currently of the inactive phase of the MJO. This active phase has been holed up right here over, well, mainly India in this area for a month now. The inactive phase has been here for a month now, but this forecast suggests, and it's been continually suggesting this, the statistic model, that the inactive phase is going to fade out. The active phase is going to work its way into the West Pacific. That would be a great situation. It's still very perplexing, though, because during a strong El Nino, you should have no MJO at all, but in fact, we do have it. Now, here's the better news. The dynamic model is now hinting at a very similar sort of situation. These two models have been in directly opposed to each other for a month now. Finally, it is starting to suggest the inactive phase fades out, and the active phase starts working its way east, but not nearly as strong. Look at this. See, look at strong inactive, strong active phase 2 weeks out. This model has both of them going to nothing. You know what, though? Either one of these outcomes would be fine, because it would allow the El Nino base state to take over. An El Nino base state is supportive of westerly winds in the Kelvin wave generation area, and therefore supportive of a stronger jet stream. So this is exactly what we've been hoping we would see. And the GFS model that we just saw showed about a week out, somewhere in here, that westerly winds will start building south of the equator. So all the models are now starting to sort of pick up on the same thing and suggest that maybe a week out a change will start happening. And yet another way to look at the MJO, this tracks the active phase of the MJO, and you're sort of like looking at a cross-section of the Earth, the Indian Ocean to the maritime continent to the West Pacific, over the U.S., over the Atlantic and Europe, and then back to the Indian Ocean. Currently, the active phase, medium strong over the maritime continent right now, and the forecast per the ECMF model is that it'll stay reasonably strong, work its way into the West Pacific, and then peter out. This is 2 weeks out. The other model, the GFS Ensemble, says something similar, making it to the West Pacific and then dying, not making as much headway. So this is sort of similar to the two models we saw before, the statistical and the dynamic model. So a similar outcome. Either way, active phase is supposed to make its way east. That's what we want, because that'll get the inactive phase out of the Kelvin wave generation area. That'll stop the destructive interference that's occurring with the inactive phase and El Nino, and this will allow El Nino to finally wake up and start doing what we've been wanting it to do for a month now. We've seen this chart before, but it goes in reverse. Past history is down here from the bottom. The forecast is going up. Oranges and yellows are westerly anomalies. Currently, here's kind of the muddled period we've been going through since November. A little bit of a westerly wind burst there, but the last big westerly wind burst was here in the October time frame, westerly wind burst number 4, which created a massive Kelvin wave. We've sort of been suffering. What the model hints at, though, is come the end of December and January, another solid burst of westerly winds are to occur. That aided by, here we go, the active phase of the MJO right here. Here it is all bottled up over near India, slowly working its way to the east. This model suggests that by about Christmas time, maybe a couple of days after that, it's finally going to make some real headway into the West Pacific, and with that, westerly winds develop. Now notice also it suggests the inactive phase is to reappear come late January and shut us down into the end of February. Then March it wakes up again. Also, let's take a quick look here at equatorial Rossby wave activity. Not a whole lot going on that we're seeing. And then, of course, the low pass. This is the strength of El Nino over the entire region. Basically, El Nino, according to this, is quite healthy. It's all, everything's lined up the way it should be. It's just this inactive phase of the MJO here has been suppressing westerly winds in this region, and as soon as that's out of the way, we should be back in business. The storm track should be healthy, and again, per the data we just seen, we're only about a week out or so from a week to 10 days from that for happening. Now the key is going to be, does this week to 10-day window always keep extending another couple of days every time you look at the model? That's the game we've been playing for a month now. So, I don't believe the models at all right yet. But there is more consistency in the models and across different models, and they're all starting to coalesce around the same sort of outcome that points to about a week from now, something starting to change. That's exactly what we want to see. All right, so we've talked about westerly winds and the MJO to death. What that does creates, of course, westerly winds here. This is the West Pacific. This is the East Pacific. We're now looking at at depth, 2 degrees north, 2 degrees south of the equator from the West Pacific to the East Pacific, because we are looking for these westerly winds. They push warm water at the surface to the east, but what really happens is that warm water falls to depth, creates a bubble of warm water subsurface that then travels the whole way across the Pacific and erupts over at the Galapagos Islands, a Kelvin wave. Currently, we see much warm water moving to the east. The 28-degree isotherm is at 120, where it's been for months now. No particular change, but we do see 30-degree temps continuing to slowly ease their way to the east. But this 120 line, one would think it should be more like over at about 100 or so. This speaks to the westward displacement of this El Nino. Now, looking at anomalies, differences in normal for this time of year, same picture, but what you clearly see is a giant pocket of warm water here off of Ecuador and the Galapagos, actually down to about south of Hawaii or so, right here. That is, westerly winds take warm water, push it to depth. You can see it here, warmer than normal temperatures, 7 degrees above normal. This is what we're calling the warm reservoir. It's really these warm water pockets. Kelvin wave number 4 was the last one, big one, just sitting here. And again, continued westerly anomalies feed warm water into this area, so it's not completely dispersed yet. Here's the higher res view. You can clearly see warm water falling to depth. Here's the large pocket or reservoir. You can also see it erupting to the surface here between about 125 west to, about 105 west. So when we get to the surface charts, we'll see if that's really the case. And we also see fingers of this now trying to work its way into Ecuador and that area. This has kind of been oscillating back and forth. Most of the eruption site, though, is well west of the Galapagos. Also notice cool water here. Perhaps the upwelling phase of the Kelvin wave cycle, but it also might be the demise of El Nino. This is pretty normal for this time of year, or this point in time for the maturity of El Nino. At some point, this reservoir is all going to erupt to the surface and collapse, and then cold water will build in behind. But for now, the cold water is being held at bay. We really need more. If we got more westerly anomalies, that would hold it off even longer. And we've seen this chart before too, JSON2 data. This is sea surface height anomalies. Differences normal for this time of year. Strip out all the waves, strip out the tides, everything. And what you see is this sort of bulge of 15 centimeter. The ocean's 15 centimeters higher here and less so, but mainly right over top of where all that warm water is. Also notice below normal here, suggesting cooler than normal temperatures here. The point being, warm water at depth expands. It actually causes the ocean surface to bulge up. So this is a good indicator of where warmer than normal water is. So basically, this image just reaffirms what we saw in the previous image, that a large pool of warm water subsurface, the reservoir, is here, west of the Galapagos, not working its way into the Galapagos in Ecuador, but mainly the core of it is sitting out here west of there. And then our favorite chart, upper ocean heat anomalies, West Pacific here, East Pacific here. Time, January 2015. You see the last part of a Kelvin wave that worked its way into Ecuador. This was last year, a year ago. Upwelling phase of the Kelvin wave cycle. Temperatures cool off. And then, boom, one Kelvin wave this year in March, April. Another in the May, June timeframe. A super strong one, Kelvin wave number 3. We were majorly impressed by it. It occurred in the June, July timeframe, fully erupted into September. And then beyond that, even another larger Kelvin wave number 4, which developed in the, when was that? The October timeframe, up till about the end of October, caused by a major westerly wind burst. And then you can see it is now starting to pretty much wrap up here as it erupts. Notice not into Ecuador, but again west of the Galapagos, westward displaced. Now also notice here the temperature gradients here are starting to push back to the west. There is a very weak bit of westerly winds that we saw in the charts in the November time frame, and we think that that might actually be starting to form yet another Kelvin wave, or at least preventing the complete collapse of the reservoir, which is a very good thing. And if westerly winds do develop in the next week or two, that will only feed this again. Maybe we'll end up with a legitimate Kelvin wave number 5. That would just extend the life of this El Nino. I mean, it's already pretty much good for, the whole winter season. There's still plenty of warm water subsurface, but maybe this will just keep it going a little bit longer. Okay, next up on the tour is sea surface temperatures. Now notice this data is old. There must be some sort of a computer anomaly going on at the NOAA site. But this is the high-res data. We'll go with it because we don't think anything's changed too radically different, though we love to follow this day by day. But so we're a couple of days off. It won't. By Monday, I'm sure they'll have this resolved. Anyway, classic El Nino signal. The reds, the oranges are warmer than normal temperatures. Very much a lot of warm water here between the Galapagos out to the date line. Classic El Nino signature. Now not as pronounced as the 97 El Nino, which had a lot more warm water in this area here. Most of our warm water is displaced out here. In fact, the temperatures from Nino 3.4 a couple of weeks ago surpassed those of the 97 El Nino, and it's really the area from 120 5 degrees north or south of the equator out to 170. That's the main monitoring area for measuring El Nino. And so in some regards, this is very similar to 97 in terms of absolute temperatures. But another way of looking at it, if you go over to the Nino 1.2 region right in here, temperatures aren't even close. But all it says is this El Nino is a bit westward displaced, still fairly strong. What we really want to see is more westerly winds taking more warm water here, pushing it to depth, makes the trek across the Pacific as a Kelvin wave erupts. Actually, it'll probably erupt out in here and continue to feed the warm pool in this area. This is trend data for the past 7 days. Again, actually, it's about 5 days old now. But still, you can see not a lot of warming so much here between the Galapagos and Ecuador. This has been going on for a while, though, here. Warming off of Peru and Chile. Also, patchy warming from 120 out, but particularly strong here between 160 and 180, and even beyond there. Again, speaking to the westward displacement of this El Nino. Now we can really zoom in. This is the high-res data, and for whatever reason, it is updating. So, we'll get a good sense of what's going on here. We'll go sector by sector. First, Nino 1.2, the area between Ecuador and the Galapagos. Warm water, little pockets of 4-degree anomalies, but most of this is 2.25-degree anomalies. We'll go back a week, look at that. Actually, it's built a little bit, and the subsurface data also suggests, up in here, it has built as well. The subsurface data suggests that the reservoir is making a push into this region, but it's done this several times. It pushes, then it backs off. It pushes and it backs off. Most of the activity is west of this line here, out in here. Now the next sector, the Galapagos, are right out here on out to almost the date line. Very, very healthy warming here. This is really interesting, though. We're seeing there has been 4-degree anomalies in this region, sort of in this general region right here, but now it's starting to build out here towards about 50 west south of Hawaii, too. Very interesting. Now, also, let's go look a week back, and what you see is it's kind of thin. Yeah, there's pockets, but there's this sort of thinness, not as much width, and then you get, now this week, much healthier warming in this area. We'll just go back and forth so you can see increased coverage of the 2-degree anomalies. Looking very good. One would expect to see the Nino 3.4 temperatures that runs from 120, 5 north and south, so basically on out to here. With this increase in the width, you would expect to see the Nino 3.4 index go up, and we'll take a look at that in a minute. And then the final sector, 60 out to 180, the Nino 3.4 region ends at 170. Very healthy warming here, but let's go back a week. And what you see is a week ago, it actually was almost reaching the date line. It has sort of receded a little bit here, but not completely. But again, from a Nino 3.4 index, the cutoff line is here. So backed off a little bit. Maybe at the for the purpose of building the width of the warm pool back off to the east. But either way, things are looking very healthy indeed. During any other year other than maybe the 97 and 82 El Nino, this is in the top 3. We saw this chart before, but we'll look at it again here. We were looking at winds. Now we look at water temperatures, and we don't get so much from this, but this one shows you anomalies, differences in normal. A clearly defined warm pool, now not working its way into Ecuador over here, but again, that displaced kind of pattern from 100 or 110 out to about the date line with 3.5-degree and 3-degree anomalies over a large area. Here's a view that puts it all together. That's not a bad view. And then also we like this view too, but this one's dated. This is the 14th, where this one is current as of the 20th. A little bit different scaling. That's the unfortunate part about it. But this one showed where the core of that warm 4-degree anomalies were from 100 west out to about 138 or so. But again, this is almost a week old now. So we've talked about westerly anomalies in the Kelvin wave generation area, and they're not really where we'd want them to be. That's all attributable to the inactive phase of the MJO, which has been in control for almost a month now, but we are seeing signs that the active phase of the MJO is supposed to take over the Kelvin wave generation area, maybe starting a week to 10 days out. Westerly anomalies should increase then. That should feed the jet stream. That should in turn help support the storm track. It also should continue to push warm water to the east, maybe extending the life of our warm water reservoir that's currently quite warm but westward displaced. That's erupting, creating warm surface water and giving us our classic El Nino signal. That in turn also helps create westerly anomalies. So it all hinges on the demise here, the inactive phase of the MJO. But at the end, it's what's the impact on the atmosphere. This, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti, when you have negative numbers, daily numbers here like that, that's a clear sign of at least the active phase of the MJO, but if it's prolonged for a month or more, then you go, oh, it's El Nino. But here we go. The inactive phase of the MJO has just been stomping on the Southern Oscillation Index, basically promoting lower pressure over Darwin where there should be high pressure, and higher pressure over Tahiti where there should be lower pressure. So our 30-day running average, it's not bad. I mean, it's minus 11, minus 10, something like that, but it should be down about minus 20, and the 90-day running average, which should be about minus 18, is at minus 14. But, you know, the interesting part is, though we've taken a hit here for a month on this MJO thing, still the numbers are not horrendous, and we could recoup rather quickly if we got lower pressure over Tahiti and higher pressure over Darwin, and that's what the forecast suggests should happen. Another similar index, again, here is this area, the Maritime Continent, or the area north of Darwin, and then the area north of Tahiti, we measure. You can measure cloud cover, and that's another way of seeing how well El Nino is coupled to the atmosphere. And you get an index number, like today's value is plus 1.4, which is actually pretty good, suggestive of El Nino. It was up to 2.4 at its highest, but it has never gone negative. It has never even got to the 0 point while we've been suffering through this inactive phase of the MJO. And you can see here the anomaly, rainfall anomalies, still a healthy rain pattern, and notice it's right over where all that warm water is, not so much over here. You know, remember we said this is westward displaced. Well, that's exactly what this is showing as well. But also notice you're picking up rain here in Darwin and off in this area, and that's all the sign of the active phase of the MJO here. Now, what will happen is as the active phase of the MJO moves over here into an area that's already just ready to start dumping rain and currently is, it will only get enhanced more. Westerly anomalies will be enhanced more, and then we'll be off to the races with El Nino, assuming that's what happens. So the deal is we're looking for the inactive phase to set up over here. You'll watch all this rain disappear. Higher pressure builds over Darwin. Lower pressure north of Tahiti. The Southern Oscillation Index will go negative. The SPI Index will turn positive. The jet stream will start raging, and we'll be off to the races. And also, here's the Southern Oscillation Index. We should have shown this earlier, but we'll show it now. And you can see how here is this. When you're negative, again, you're in the active phase of the MJO or El Nino, and clearly since since even March of last year, it's been a year and a half now that we've been basically in negative territory, getting very negative in July, and then here we hit this inactive phase of the MJO thing. And we've lost a bit of ground, but we're trying to make it up. But the thought is we'll start heading negative again shortly if the MJO cooperates. And we forgot to show this chart. We'll show it now. CDAS Nino 1.2 temperature indexes. Again, this area has not been productive, and this chart shows that, 2-degree anomalies, and it's just kind of been muddling along since the beginning of November, not getting hotter, not getting cooler, just sort of there, nothing particularly of interest. But the Nino 3 region, and that's basically from the Galapagos out to, I'm not sure, 150 or so west, it was quite warm. It's backed off a little bit. This was the peak of Kelvin wave number 4 erupting at 3 degrees above normal. Currently, today's value 2.72. Very warm indeed. Normal is down here. It is very rare to get this warm of a temperature anomaly in this area. And then the Nino 3.4. This is the main one for measuring El Nino, and this is just interesting because you have 3-degree anomalies that went from, November 15th, nonstop to about almost December 6th, and then it backed off a little bit. But remember how we said the width of the warmth in the Nino 3.4 region was on the increase? This shows as well, up to almost 2.6 degrees above normal. Any other year, if you had 2.6 degree anomalies in here, you'd just be going, oh, this is a major El Nino. Clearly, we are at a major El Nino, but we've got this inactive phase of the MJO thing going on. You can see it here. That's just been sort of putting a crimp on everything, and we're hopeful. We're seeing signs, but we're not guaranteed yet that we're completely out of the woods, but the thought is we probably are. So, for now, a moderate storm pattern, mainly weather for California. Yes, there's surf. If you can find protected breaks, get out of the wind somewhere. And there's definitely going to be a lot of ocean, a lot of motion in the ocean, if you will. And so there'll be waves to be had. Hawaii, kind of out of it for the immediate time frame. Most of the activity seems to be isolated to either the North Dateline region and pushing east towards the U.S. West Coast, or the Gulf of Alaska or Northern Gulf. Even for Southern California, very north swell angle, probably not optimal. Probably this is a good time for snow accumulation and weather, if anything else. But the models suggest a week out, West Pacific storm possibly happening, the jet stream waking up, the inactive phase of the MJO fading. That will allow the El Nino base state to wake up, westerly anomalies redeveloping, and then if the active phase of the MJO develops, that will only amplify the El Nino base state and supercharge this event a little bit, so we'd get a good month-long or so burst of a storm cycle. But then if the inactive phase comes after that, then we'd have a bit of a downturn. So things looking pretty interesting for the time being. A little bit of housekeeping here. We will not be doing a forecast next week. We're in the holiday season. Most people are out of town, so we're just going to take a bit of a break, but we will be back the following week and do a forecast. Same thing for the site. We may maintain it, may not maintain the forecast, but we'll try to keep it up as much as possible. We're going to go try to get some snow and get some surf as well. So Merry Christmas to everyone. Happy New Year. Be safe, be smart, and be prepared, because it looks like good things are to come for the new year. We'll do this again 2 weeks from now. Take care. See you again next time. Same channel.